All right, we're about to crack a secret code. Seriously, it's this silent, invisible set of rules that pretty much runs your entire wallet. It explains why some things you own lose value, and other things, well, they just seem to grow all by themselves. Let's dive in.
Have you ever felt that physical sting of watching a brand new car lose thousands of dollars in value the second you drive it off the lot? Or, on the flip side, have you ever checked a savings account you haven't touched in a while and been kind of surprised to see it's bigger? Almost like magic?
Well, you probably guessed it, it's not magic. It's math. Specifically, it's a hidden pattern, a code called a mathematical sequence. And that just means it's a list of numbers that are following a very specific rule. Today, we're going to see how this one simple idea unlocks some of the biggest financial mysteries in your day-to-day life.
So first, let's tackle the not-so-fun one, the value drop. This is all about how things lose money. And you might think it's kind of random, but it's actually an incredibly predictable downward pattern.
The official word for this is depreciation. All it means is the loss of an asset's value over time. And you see it everywhere: phones, computers, and, of course, cars.
Okay, so this timeline shows the value dropping year after year. But look, it's not chaotic. A car doesn't just lose a random amount. It often loses a set percentage of its current value each year. That predictable pattern is a special kind of sequence called a geometric sequence. And that's what lets us forecast that loss with amazing accuracy.
But this mathematical code, it's not just about losing money. Now we get to the exciting part. Let's flip this around and see how that exact same pattern works in reverse to help things gain value. And here it is. This is the big aha moment. That same geometric sequence, the one that explains your car's predictable drop in value, is the very same code that explains how your savings can grow. It's the same math, just pointed in a much happier direction.
This really shows you how powerful this one idea is. On one side, you've got compound interest. That's where your money earns interest, and then that new extra money starts earning its own interest. And on the other side, you've got population growth, which also tends to increase by a percentage over time. They seem totally unrelated, but mathematically, they're basically twins.
This right here is the power of compound interest in action. Look closely at the bars. The growth isn't a straight line, is it? Each bar isn't just a little bit taller. The jump in height actually gets bigger every single year. That's the accelerating power of a geometric sequence, and it's working for you right inside your savings account.
So, we've seen how this code can make things shrink, and we've seen how it can make things grow. But what happens when you combine them? Well, that brings us to the math of loans, a really fascinating puzzle that affects pretty much everyone.
So the key idea for a loan is something called an annuity. It sounds fancy, but really an annuity is just a series of regular, fixed payments over time. In this case, the bank gives you a big pile of cash up front, and you agree to pay it back with those fixed, regular payments.
Now, the really clever part is how that payment is structured. It's a balancing act. Every single month, your payment is doing two jobs at once. A portion of it goes to cover the interest that built up that month, and the rest of it goes to chip away at the original amount you borrowed. That's called the principal.
Just take a look at this simple table. With that very first payment, you see a pretty big chunk goes to interest. But as the balance goes down, the interest portion of your next payment gets a little smaller, which means more of your money goes toward paying down the actual loan. It's this beautiful systematic sequence that guarantees the balance will eventually, predictably, hit zero.
So once you see this pattern, you just can't unsee it. This stuff isn't just abstract math class theory. It's the hidden code that's running behind some of the biggest financial events of your life.
From the depreciation of the stuff you own to the compound interest that's hopefully growing your savings, even in big scientific models of population growth, and especially in the structure of the loans that help us buy homes and cars, it's all the same underlying mathematical pattern.
And that's really the main takeaway here. These sequences, they aren't just problems you find in a textbook. They are the fundamental rules. They're like the operating system running in the background of your entire financial world.
So I'll leave you with this question. Now that you can see the code, now that you can spot these patterns of predictable change, what else out there in your world do you think is being run by a hidden sequence? I'm actually really curious to see what you find.